Okay, lovely. Thank you. Thanks everyone for coming to this workshop, which is hosted by myself, Lindsay, and Surya here from Age Check. So I'm Lindsay. I'm from a company called Select Statistics. I'm a statistician by trade, but I've worked with Age Check, assisting them with supporting them with their statistics in terms of their accreditation and some ISO and Ofcom work that Tony and I have been working on over the last couple of years. So this workshop's about data visualization for results of age estimation systems benchmarking. And I was going to start off with a sort of general few slides on why visualization is important, and also just some resources that I think are really helpful. And then I was going to pass over to Surya, who's going to look at a specific use case in the age estimation sphere. So does that work? No. How do I go down? Page now?
Can you show the whole screen of PowerPoint? Because on my side it is only this file.
Oh, okay.
Maybe
Is something going on? Okay.
Yeah.
Okay. Perfect. Okay.
So strange. But anyway, it's just me and you.
Okay.
Oh yeah, it's working now.
How do I? Oh, here we go. So, working?
Yeah.
But also, oh, here we go.
Oh, yeah.
Yeah, there we go. Okay, so why is visualization important? Okay, so from an analyst perspective, it's typically one of the first things that we'll do is look at our data. What does it look like? What's the distribution of our data? You know, when we do a lot of statistics and statistical models, there's a lot of assumptions about the data. We need to check those assumptions, make sure they're correct. If we've got data over time, are there clear trends over time? Is there seasonality? If we've got multiple variables, are there patterns or relationships between variables? Does the data suffer from outliers? So visualization for an analyst is hugely important as a tool for understanding what analysis should be done, what the data is showing us. So as an analyst, it's a hugely important part of our toolbox, but it's also an important aspect of communicating results to an audience in a simple and efficient manner. So, you know, rather than trying to explain a concept using lots of text, a simple visualization can be a clear and effective way of showing something to your audience. Okay, so data visualizations can take many forms. So some are more technical than others. So, you know, charts and graphs, maps. Some are interactive through dashboards. Some give you like the flow of information, like flow charts. And we've got things like dashboards, but really all of them, we're very much looking to accurately summarize our results. You know, here are a few examples. So for example, on the more technical side, you might have density estimates when you're looking at the distributions of your data. So what's the modal value, where that peak is, what's the spread of your data? Is it Gaussian or normally distributed? Are there other distributions here? We've got comparisons between two categories, so male and female. We've also got things like box plots. You know, box plots are a different way from densities that tell us about our distribution. It tells us where the middle of our distribution lies. That's the yellow line, the median. It tells us where 50% of the data lie. That's the quartile 1 to quartile 3. But it's also a really useful way of, for example, looking to see whether there are outliers in the data. We've also got things like if your data is binary, a receiving operating characteristic curve, which tells us the performance of a classification model for different classification thresholds. So these are the sorts of visualizations that you might do if you're looking at something more technical. But also we've got, you know, things like simple flow charts. So if you're trying to say, well, here's my age assurance technology and here's the flow of work. This is how it works. You know, this is how our technology works. And you might have a flow diagram. And then you've got things like infographics. I found this quite nice infographics on the Future Privacy Forum which is all about unpacking age assurance, the technologies and the trade-offs. So it's kind of more for public consumption. And it's showing us what the different types of age estimation technology is, what they do, what the trade-offs are, what the risks are. It's quite a nice infographic for somebody coming into this area who doesn't know much about age assurance and wants to pick up detail. So visualization spans a lot, you know, from the very sort of more technical to, you know, things that are, you know, much more user-friendly. So I just wanted to, before we go on to a particular use case for age assurance, I just wanted to like point out what I think are some useful resources for data visualization. So last year, so the Royal Statistical Society is a UK-based society for statisticians, and they have lots of courses and lots of information. And so, for example, I'm a chartered statistician, so that I get that through the Royal Statistical Society by showing my qualifications and my CPD, etc. But last year they put together this best practices for data visualization resource, and I think it's really quite a nice sort of user guide if you want to do some visualization. You know, so they've sort of talked about the fact that a successful data visualization will grab attention, will improve access to information, will increase precision, will bolster credibility and summarize content. They've got a lovely section at the beginning about historical visualizations, you know, what the ones, the famous, like there's a famous Florence Nightingale visualization, for example, which was one of the first really lovely example of where visualization has been used really effectively. But it also goes into like lots of more technical content. So it sets out guidelines and principles, like the best way you might lay out your visualization, you know, aspect ratios. So you have to be really careful with your aspect ratio because you could mislead the audience. Thinking about axes, what scales they're on, the orientation, you know, so for example, if you've got like a bar chart, you could have it horizontally, but actually sometimes vertically can be more helpful for somebody. And then they've also got lots of information about colors. There's a huge, like, not huge, but there's more discussion now about what colors you should be using, making sure they're accessible, making sure you're not, you know, like impacting someone who might be colorblind, for example. So I just think this is a really nice resource if people want to put together visualizations. And then they point to a couple of other websites, which I think are also very nice. Which kind of help you decide what data chart you might want to use. And it sort of depends. So there are two different ways that you might think about this. It's thinking about what type of data you have or what data relationship you're looking into. So I'm hoping if I press this, it's going to take me to the website just so I can show it to you. Maybe. If not, I can just, let me just, is it working? I should have gone to the website to begin with. It didn't work. If I just go here. Oh, here we go. It is loading. Slowly.
You can exit and reload it.
Pardon?
You can exit the page and reload it.
I should have had these preloaded. Okay, but it's not a problem.
Yeah, I can share this.
We can, I'll go back to, now the laptop is completely unhappy. Ooh.
I can share the screen.
Oh yeah,
Yeah,
okay.
you can start sharing and I do that.
There we go. I mean, it's not necessary for us to have to go through it. But basically the idea, so this data to biz is really nice because it effectively what it does is it goes through. So you can have a look and say, okay, so I've got a numeric variable. I've broken it.
It's just stress pain.
Oh, sorry.
Yeah, it's
Okay, so basically, if you go on the website, it's interactive, it's very nice. I would highly recommend it, but I'll just show it from here. But basically, what you can do up here, it's a really lovely resource and it does work if you're not actually presenting. It's like yes, no, maybe, or 1, 2, 3, 4, 5. It's a Likert scale. You've got numeric and categoric, you've got maps, you've got networks, you've got time series, and then you can say, okay, I've got 1 variable, I've got 2 variables, they're not ordered, they're ordered, there's 3 variables, there's several numeric, and it just goes through all of the different types of visualizations that you could produce given these different kind of types of data, and like what their pros and cons are. And I just think it's a really nice visualization tool. Right. I have no idea where I am now on this.
yeah, but oh yeah, I share the screen now. So
Oh,
this is a website. I think there's a lot of
okay.
icons you can click.
It's not,
But it's not here.
yeah, it's okay. Don't worry, it's
Yeah.
fine. Can I go back to my screen and then I'll just go back to the
Yeah.
presentation? And then the other one that I wanted to show you.
Yeah, it's broken.
All right, it was on the corner, it wasn't on the laptop, fortunately. And then the other there we go. And the other one, oh, this laptop is completely.
Yeah, definitely need an up page of this laptop. It's well,
There we go.
yeah.
Perfect. And then the last one is this other one called Visual Vocabulary, which was put together by the Financial Times, the people that do the visualization to it. And so they've looked at it from a different, so whereas that other one is about the type of data you have and the types of visualizations you can do, this one is more about what relationships you might want to be looking at. So it gives you the different kinds of visualizations you can do if you're interested in deviation. So if you're interested in looking at changes from like a fixed reference point. So for example, I'm just trying to think, you could be looking at, you know, absolute errors where 0 is your middle and you've got different age ranges, but then also correlations, changes over time, ranking distributions, spatial. So it basically just gives you the different types of visualizations that you can have depending on the actual type of analysis, the data relationships you're looking at. So it's kind of 2 different ways of thinking about how you're going to put your visualization together. But I think they're both really interesting resources. So that's just a quick whistle top tour on a general data visualization and some really useful resources which might be helpful, I hope. And I was going to pass it. Do you want me to?
Yes, please.
Yeah.
Yeah, next. So I just want to quickly brief about the effective field of vision. So basically, a viewable area by the sensor, image by the sensor is the field of vision, basically. And in terms of age assurance system, so the clients which we deal with, they have like cameras at different angles. Yeah, they have cameras at different angles where they try to estimate the customer's face and detect if they are over 18 or not. Let's say I want to buy energy drink that requires me to be above 16 something. So this is being deployed in the retail stores, and they try to get they position the camera in different angles, and the effective field of vision basically is the peripheral vision, which is this side. So the combination of the right eye plus the left eye, this is the effective field of vision. So clients for age assurance system, they want to deploy cameras in these angles, And what could be, we are here to brainstorm, I guess, what could be the best way to visualize this. Yeah, next one. So basically, I'm in a retail store and they want to estimate my age based on the image. I mean, from my face based on the position of the camera. We don't usually play around with the vertical positioning because it's going to be static. We don't want to get an angle from this above or below. Basically, because the facial points, most age estimation systems which we deal work with the horizontal like vision and not like moving around from a different angle, because that's not going to capture the entire facial points. So this is the optimal horizontal line basically, and with this 60° minus 62 plus 60, this vision, what could be the, so they are estimating different ages and we run few results, basically something like a mean absolute error of the actual age versus the predicted age. And we want to explore ideas which can be the best visualization to represent the mean absolute error, let's say. For example, if the age estimation system estimates from minus 60 as 21, and but the customer is just 15, it's ineffective. So what could be the best possible way to deliver it to a client and say that this is the most effective point at which your system is working well? Next slide, please. Yeah. So the results which we usually deal with are like based on the predicted age or the age range. Some clients like work best with age ranges. So what are the results which we are talking about? It could be like the predicted age or the age range. Like this case is like from 18 to 21, something like that. Also, the data distribution, we evaluate the client based on mean absolute error and the standard deviation of the absolute error that the result is retrieved. Now, when we are talking about effective field of vision, the camera angle will also play an impact in this, and that is where when we were discussing and we were using those resources, like it would be best, would it be best to use a scatter plot or something, or a histogram? And like when there is one categorical variable, that is the camera angle, along with, let's say, the mean absolute error, or the standard deviation of absolute error. Any ideas like we can go for?
So I've done a similar study for recognition. So biometric recognition. So I plot false reject rate against theta, this angle here, the raw angle. So everybody in face recognition understands that historically recognition, if you compare a frontal photo like a passport photo against an off-angle photo, this was a very difficult problem of face recognition to solve. There's been a lot of progress on this. And you can see that in the visualizations that we produce. So you see, instead of recognition error rate going up, it's now flat and low. You can do it also if you have pitch angle as well. I think you're not interested in pitch angle, but I'm very much interested in knowing if you have data on MAE versus your angle. You have that? So
yeah, at different angles we capture. So basically we have these angles,
yeah,
like camera position 1, 2, 3, something like that, and we have the MAE at each of these angles.
what happens? Does it work?
No. Yeah, we were able to capture this, and the MAE scores best at when the camera angle was positioned right in front at 0°. But technically, when in a retail store, it is not going to be feasible to have the camera angle right, because that is where the checkout till is going to be. So that is not going to be feasible when we try in terms of like when we actually deploy it. So we wanted to, the client basically wanted to see if there are any other angles that work best. So we can just tell that this is fine, but in terms of visualization, we can say that MAE is best, but we wanted to compare and explain to the client like, which visualization can be better. So that's where the goal is to brainstorm the ideas for this.
I think our project, we did have some data, but we didn't make a data visualization about that. So this, yeah, so it's a fair point that if we will add more data visualizations of the angles, like the theta over these rates, standard deviation of the force rate stuff. We will definitely add it to our report.
It's just like the camera angle one, we did not capture the theta, but like the position 1, 2, 3. But what visualization can better explain the client, we were not entirely sure about.
So I guess the client is interested to know, can it work at 50 degrees or something? And so if you look at the distribution of MAE, are there many values where MAE is good? So you can look at the mean. You could do a box plot frontal, a box plot here, and a box plot over here. And I guess MAE will go up over here and low here. I think that's what I guess.
Because I think box plots, when you're comparing multiple categories, can be quite helpful compared to histograms. I feel like they're quite a nice way of comparing the distributions of the data.
Yeah.
You could do a violin plot as well. If you've only got a few hundred data points, you could just do a scatter plot and just show the dots, and you just you displace them a little bit this way, but you display the dots, and that way you will show are there any outliers and there are any low outliers, and then you would wonder, well, why does it work sometimes and not other times?
How about heat maps?
Yeah, I like heat maps, but I think you've only got one variable going on here. You don't have two. The one variable is this angle. If you have this angle too, then you could do a heat map.
Yeah, with your MAE.
And then it would be a bowl. It would be a bowl like this, and it would be best at the middle, probably.
Yeah.
Now, if the developer, of course, has got opposing variants, then it would be a boring heat map. It would be a flat heat map.
What's the objective of the client? Was that they're trying to do? They trying to position the camera relative to a kiosk.
Yeah. Which angle would be the best for them to do?
And why wouldn't they just try and get it like at the most straightforward phase?
No.
I guess it's impractical because when you go to these checkout kiosks, it's the screen, isn't it, and the peaking. So the camera is typically here, isn't it? Yeah.
Close to the screen where the units are looking
Yeah.
and capture it. And particularly when they do stuff at the top of this thing where the camera is, that's when you capture your picture.
Yeah.
Design the system to get the people to look where you want them to look,
Yeah.
and then capture it then, and it reduces your likelihood of being on over shot. You can bring that camera close as possible, and the focus of interest of the person is closer to where the camera is to reduce both of all of the ranges.
Also, are they just interested in the mean absolute error? Is it estimating someone's age, or is it estimating whether they're over 18 or is it over 25?
It was a predicted estimating only the
It was only the age, so what you weren't interested in like false positive rates or anything like that? No. Yeah. Okay.
So you mentioned SD, and it's been put into the standard. I think it's in the standard, and I don't know why it's useful. So we've seen an algorithm with low SD but high error. So the way SD is defined is the distance from the estimated mean,
Mhm.
not from the ground truth, from the estimated mean. And so you can be wrong all the time, but consistently wrong. So
Yeah.
SD is low, but you're very wrong.
I guess you wouldn't report one without the other.
Yeah, but why?
Yeah.
MAE captures it, sort of.
Yeah.
So
Yeah.
you could, but I wouldn't put it in the standard with the shells thing.
No, no, no. I think it's nice to have a measure of variability in of, you know, when you've got your, I guess the mean absolute error doesn't, no.
So
When-
you're very much interested in, got a distribution of error, right?
Yeah.
And everybody assumes it's Gaussian,
Mhm.
it's probably not. And it may be asymmetric. You can
Yes.
have left tails, you can have right
Yeah.
tails, and these things are application important. And SD is some width, you know,
Yes.
it's a computation of this width of this thing, but it doesn't really tell you what's happening with the head.
No,
Are they heavy tails? Are they
yeah.
very light?
So you would need some measure of skew, like kurtosis, or
You could,
I mean, maybe it's just the plot. The plot is the thing that you need.
yeah, but the tails can be, you know, you can plot. I don't like histograms because you need a width parameter.
Yeah, that's the problem with histograms, is that they're user defined. Yes, that's why the box plot, I think, sometimes can be more helpful.
Yeah, and also just a scatter plot, so people can see, look, it's distributed. And there's no outliers, or there's lots of outliers. You can just see them, but you can't do scatter plots if you've got 100,000 data points. Because your file gets really big.
Yes. Yeah, absolutely.
And it causes your PowerPoint presentation to stack. So did you do this just, the camera just took a photo
Yeah,
and then you saved the photo and then you did age?
yeah, we send it to the client and they estimate the age,
Ah,
their feedback.
If the vertical position of the camera is fixed, does it fall differently, you know, for people at different heights, right? And, you know, stand in different positions as well relative to a case, like people lean on one side of their leg or something. So, you know, I don't know if there's, it's probably going into the questions which are not in scope, but there are other variables. Like,
it's quite interesting because the community of interest here is people, teenagers trying to buy alcohol. Teenagers are growing, so they get taller. So a 13-year-old buys alcohol, and they might be 6 inches below where they are when they're putting that up. So this pitch angle might matter.
well, they'll send the tall one.
Well, if you're going to talk about,
It's also that the inclusion isn't it, because this is found during the sandbox trials, which so I thought this session was going to talk about the issues that we found during the sandbox trials where the cameras were fixed. And there were issues with identifying, you know, it was you couldn't people in wheelchairs, for example, couldn't use the system, so it's discriminatory in that respect. And then there were issues to do with, you know, too many sort of things in the visual image of the camera, and it got confused. So I don't know anything about, you know, what you're talking about really, but what I do know is that I thought that we couldn't have a fixed camera, and so I sort of think along the lines of when you go through customs at the airport, the camera moves, doesn't it, to detect you, and I would have thought that we would have to have something like that, because how else are you going if you can't determine age with a fixed camera? Because of different heights and disabilities and everything, then isn't the only solution to have one that moves up?
Yeah. I think in some real case, the camera can be put on the desk, which is from this angle. Like sometimes the camera can be from this angle, so I think you definitely need to add more vectors, which is about the height, the relative height between the camera and the middle of the face.
Yeah,
So in that case, the visualizations will not be like one dimension over the data. So there will be like two dimension, like you see the angles and the
and
height,
the height,
and
yeah.
maybe some like the distance between the face and the cameras.
But then in the airport, they also have this, the oval shape, don't they? And you have to put your face in that.
Oh yeah.
So I would have thought that we would have to go along those lines because supermarket, you know, the sandbox trials were effective. There were a lot of issues identified with the cameras, you know, and the type of lighting that affected them. Some, you know, if they were facing windows, sunlight came in and affected them, and sure people couldn't use them. So it's sort of.
Yeah, based on the quality of the image, there were a lot of results that were voided because, let's say, so the system did not yield the estimated age, and it just gave out error. So we had to discard the ones which gave error as well. So when it is not able to capture the expected, like when the image is not of the expected format, then the error was returned. So we discarded that from the analysis.
You capture, you ignore that, so you didn't really track what the failed requirements.
Sorry?
If you were ignoring those things, you weren't really picking up the failures or requirements, it was like capture some sort of sample process. This is analysis of the sample, you're not really tracking how many things did we capture that we couldn't actually process, or did you not capture anything at all? We talk about the visa thing there, now you were doing a system for that system. If you were short Indian woman, long hair, up one, up again, goes up, down, up, down, up, and down. Good not finding. There's a, if you're not tracking that, I failed to capture us. Those people won't be in the data set, but it doesn't work then.
We saw an iris camera a few years ago that people with very pale eyebrows, it wouldn't see them. The face detection failed, and the camera just didn't trigger. Nothing came. So what you end up with is sensor failure.
Yeah, I think that was all of this.
Yeah, that's,
Yeah.
that pretty much is it.
Does anyone else have anything that they wanted to talk about in terms of visualization or any questions?
So we were talking this morning about the buffer. It's a challenge 25. So it's the legal age in the UK for alcohol is 18, and 25 is the sort of convention to. In the States, the legal age for alcohol is almost everywhere at 21.
Yeah.
And I wonder if the 7-year buffer should still be, is 7 years the right number? So should they do challenge 28?
28.
And I don't know the answer to that, but what you can do is you can plot false positive rate. No, you can plot the actual age of the person against the challenge age. As a heat map, you can say how many people of age 17 are classified above the age of 30, or above the age of 29, above the age of 25.
Yeah.
And then you get a heat map. And so pretty much everybody over the age of 30 is classified over the age of 25. Very few people aged 12 are classified over the age of 25. So you get this you get this, nice heat map.
which would give you a feel for where that challenge age potentially could be or should be set.
Right.
I also wondered whether you could do a rock curve where you'd have your sensitivity and your specificity for each of the challenge age. And then you could say, where's the, I mean, yeah, where's the optimum point? I thought that would be another one as well.
Great. You need to know something about the cost or consequence of a mistake.
That's it, because you might want to wait. You like, sometimes it's 50-50 for sensitivity, specificity, but I don't necessarily think that would be the case.
Like we got at the last session.
Yeah.
It's like the operating point is depending on the use case. And you want to know what a distribution is, so you pick the right thing for your use case.
I think you actually done all this, though, seeing charts on this, like, you know, then had age 12, it was like a bar graph thing, bar chart thing. But something to do this, it's, you know, this, we the big differential and we were saying with age estimation technology and digital visualization, those times when become obsolete. And they were very much of the opinion that no, it seems that 25 at this point in time for the age information system is the optimal age. That is the nearest guarantee that you can get to put it accurate. They said at some point in the future you can maybe get it down to challenge 23, but nothing below that age would be accurate enough.
I think the last section was saying is that it's very easy. Two people of the same age to look very differently in terms of what you estimate their age to be. So there always going to be some sort of distribution of what we're trying to make that distribution small enough so it doesn't inconvenience people, but then big enough so that we don't let the wrong action happen.
Yeah.
And that wrong action may be dependent on risks of it's alcohol, cigarettes, or video game, or those buffers maybe you might want them to be different.
Yeah.
Depending on what the implementation is.
I don't think 7 years is well, I imagine. But from 25 is
As a 7-year window, because people from age from 18 to 25 might change quite a bit.
yeah.
But the US is 21, so how would it put our 21-year-olds to 25? So they still have a challenge 25.
Yeah.
It might still work.
Yeah.
But unless you've got that data, that map,
Yeah,
you
you
want to
do.
make that decision. So, well, if I set the age range to 25, actually I'm still 99% accurate versus my 99.9% accurate on at 18, because the people who are older than 21 just tend to look old, don't look 18.
Is the ACCS, is that right? Does the ACCS look at demographics?
I'm right.
Do you look at demographics? You do, don't you?
Yeah.
But by age and skin tone?
Yeah, skin tone and gender, we classify them.
Okay. Yeah.
Yeah.
And skin tone comes from, where do you get that from?
Fitzpatrick scale.
So you look at the image and come up with a Fitzpatrick.
Yeah, so 1 to 2 will be one category, and 3, 4, and 5, 6.
Yeah.
Based on
What's your kind of experience been with data visualization and you're talking about presenting to a client here, which formats work best for different audiences? Because sometimes you want to use it to support, say, like requirements and standard or something, but other times it's about kind of convincing leadership or motivating policy and change.
I think understanding your audience is probably the key thing. And, quite often my audiences are probably more on the technical side of things. So, we'll use scatter plots, bar charts, those sorts of things to illustrate our results. I think when it's moving towards, because I think even your clients are probably quite technical, it's Yoti and do you know what I
Yeah.
mean? And then quite often when we're working with somebody that something's going into the public sphere, there'll be another party that will come in and do like infographics and things like that to take some of the key points and make them much more condensed, I think, and user friendly if it was to go into the public domain. Yeah. But yeah, I don't know for you guys what sort of visualizations you typically use. I feel like your clients are quite technical, aren't they? Yeah. Anything else? Sounds like we can finish a little, like give everyone 10 minutes to get some tea or coffee before the next session. I feel like it's a busy day today. It's a lot. Thank you.
Thank you.
Thank you.